All right, let's get started. So before we continue with what we left off on Monday, I would like to draw your attention for the plan for upcoming weeks. So a quick reminder, there will be a midterm next Monday, 9 to 9:50. And it will cover all the materials from week 1 to week 7, include week 7. So from lecture 1 to 4, include lecture 4, lab 1 to lab 6, quiz 1 to quiz 6. And if we are late, there will be no extra time will be given. And so in particular, quiz 6, which you are going to take today, will be part of the midterm test as well. So solution to quiz 6 will be discussed at the end of the recording of week 8b. So after the class, I will upload the recording for this lecture. At the end of this lecture recording, there will be a solution to quiz 6 discussed as well, okay? And so please check these solutions. Please watch this video towards the end. There will be solutions to quiz 6 and understand the solutions because it will be tested in your midterm, okay? And so I have been informed that there are many tutoring hours available to you every day. There is at least one tutoring hour, either on Teams or in the tutoring center. So I encourage students who have low scores on quiz to utilize these resources to attend the tutoring hours. And today we're going to continue our discussion using for loop to accumulate numbers or to count or to search something. And some of the questions that are presented in lab 7, which is this week lab, will not be covered in the lecture today. So please watch the mini presentation lab 7, which I have already uploaded. And please watch this before the class, before your lab sessions to understand the idea behind of why we do it that way in the lab, why I presented the exercise in that way, and why there is a limitation on using for loop. Okay, so in our subsequent lecture, we will be discussing a different iteration called while loop, which will cover some of the limitations that is posed by using for loop. Okay, now and there will be no class on October 11, 12, and 13. In particular, there will be no lecture on October 11 and no labs on 12 and 13. Okay, and the grades for midterm will be released latest by Monday, 16th of October, and which is also the last day of withdrawal. We will try to give it to you before that, all right, but the latest will be Monday morning, all right? So you still have time for withdrawal, and it most likely will be released by Friday next week, okay? Any questions? All right, if not, let's continue with our discussions for loop. So we start off with, on Monday's lecture, we start using for loop to sum the numbers or sum some elements inside a list. Okay, so when we started with for loop, we say we use for loop to iterate over something iterables, and we can display them. And then we can incorporate if and else inside to display those that we are interested in. And then we continue and say that we are not just displaying, we can also manipulate manipulate the numbers that we iterate over. For example, we can sum up these numbers, okay? So in particular, we start off using for loop to sum elements inside a list. So for x in quiz, we're gonna add the value of x to result. This will sum up all elements in quiz. And say that we are only interested in to sum some of the elements, so we incorporate if statement inside. If it satisfies certain condition, then we add it into result. Otherwise, we ignore it, okay? But you still go through every element in the list. So for x in quiz, that means you examined every element in quiz, okay? You take out every element in quiz and then you examine it whether it is satisfied this condition. If it is, you add the value of x to result, all right? And then we come to learn how to do counting. All right, so sum and count are pretty much the same idea, except that for counting, we're gonna do something different. We're gonna do something, analyze it more. So every time we started off with some problems, we should think, can we use built-in methods first? Okay, if we can use it, why not? All right, for example, if we can sum off the element using the built-in function sum, so we should do it. All right, and the same thing, if you want to count, for example, the number of students who get score 3, you can just use .count method, which is already built in for you. All right, now it becomes an issue when you want to do something more than that, not just counting one element, not just counting 3. Say you want to count number of elements that satisfy, say, score less than or equals to 3. Then you start to think, can I still use a built-in method? Is it wise to use built-in method? So here we assume that all scores are integers. So it seems like we can still use the .count method. You're going to count the number of elements with number of students with score 0, count the number of students with score 1, count the number of students with score 2, and count the number of students with score 3. And then you add them up. Okay, this will give you the sum of all the students with score less than 3, assuming that all scores are integers. All right, now this expression here required to explicitly write them down, this summation. So instead, we're going to use a for loop. So every time you see something like this, that you have to explicitly write it down, you know that you can use for loop to automate it or to iterate it. All right, so we're going to do the same as before, where we sum up this number. All right, we're going to for I in range 4, because this will generate integers from 0 to 3. And then you count the number of times students get this score I here and add it to result, where result was initialized equals to 0. Okay, so this code here essentially do the same thing as this code here, except that we run using for loop without having to explicitly write down quiz1.count for each of the possible values that we are looking for. Okay, now what if, so this is to come with the assumption that all scores are integers. Now, what if it can take non-negative integers values? Okay, so say, gonna do, assume that now the quiz scores can take value such from 0, 0.5, 1.0, 1.5, and so on, 3.5, 4.0, 4.5, and 5. Suppose it can take this number of values. Okay, so it's either integers or it's 0.5 of an integer. Okay, suppose it can only take this. All right, so again, you think, can I modify the existing code that I have here to accommodate that, to complete this task? Now it can take 0, 0.5, 1.0, 1.5, and so on. All right, so it won't take 0.1, it won't take 0.2, it won't take 0.1111. It will just take whole integers or integers plus 0.5. Okay, so there are multiple ways that you can modify this code to satisfy the task with minimal changes in the code. All right, so here you have generate integers from 0, 1, 2, 3. Okay, so now you think, I want to also, can I also generate 0.5? Can I generate 0.5 here? Can I also generate 1.0 here and 1.5 here, 2 and 2.5 here, then 3, 3.5, 4, 4.5, and 5. Can I generate these integers using range? Okay, so it's a good exercise. So these codes are not optimized yet. I'm going to tell you how to optimize it later on, where you don't use the .count method. But the whole idea of this is just to expose you how to analyze the code, how to figure out how you can make minimal changes to the current code so that it satisfies the conditions without having to rewrite everything. And most importantly, how to use some of these built-in functions to help you. Okay, this is a very important exercises because in the future, when you write code, most likely you will require to use some of the built-in functions that you have never seen before. So this presents an exercise for you to how to mitigate or how to use these built-in functions to satisfy the task that you want to do. So for example, I would start searching for help range. Okay, to figure out whether it can generate a sequence of integers from start to stop by step and whether it can generate, say, 0.5, 1.05 or not. So here you say that it's produce a sequence of integers from start to stop by step. Okay, so it will produce, so range ij produce I plus 1, I plus 2, and so on. Say here is say a sequence of integers. So it seems like I can't give any decimal points as a way to generate using range. Okay, so if you, so we know that it can't. Okay, so I know I can't, so it can't generate. So we're going to modify it. So we're going to think, is there a way to generate integers this using range? Okay, so by just looking at help range, it seems like it's only generate integers. So I can't do that. So what can I do? Okay, so from the help of range, it appears that it can't generate decimal. All right, so what can I do instead? So I can't generate these decimals that I wanted. So I can only use the existing code. So it generates 0, 1, 2, 3. All right. Is it 0, 1, 2, 3? Yes, 0, 1, 2, 3. So we are looking for less than 3. So it should be 1.5, 2.0, 2.5, and so on. So I actually have more here. Okay. So we know it can't generate decimals, but can we still utilize what we have here to do it? Did I say less than or equals to 3 or less than 3? Okay, it's less than or equals to 3. So it should generate until 3. Okay. All right, so we can't do that. So what can we do instead? Okay, remember here, I here takes the first iteration takes the value 0, and I'm going to count the number of elements appear, the number of times 0 appear in quiz 1, and I add it to result. And the subsequent value that I want to try is actually 0.5, but range 4 doesn't generate 0.5. However, I can be smarter than that. I can actually utilize this and say that, you know what, I'm going to do quiz1.count I plus 0.5. All right, so this will count 0 when I is equal to 0. And when I is equal to 0, this will count 0 plus 0.5. That will be 0.5. So in one iteration, I count 0 and I count 0.5. All right, and then I add them to result, which is exactly what I want. And then in the next iterations, I will take the value of 1, and then I count 1 and add it into result. And then I also count 1 plus 0.5, which is 1.5, and add it into result. So I have counted 1, I have counted 1.5. All right, then we continue. Say the next iteration will be 2. I is equals to 2. So I count 2, add it into result. I count 2 plus 0.5, that will be 2.5, and add into result. And then I count 3. So I equals to 3. And then we have count 3, but we also count 3 plus 0.5, which is more than what we need. We only need until 3. So how do we fix this? So the above code will count the total number of scores that are total scores that are total scores that are equal to 0, 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, but we don't need to count 3.5. Okay, so how should we fix this? So of course, there are multiple solutions to this. Okay, to fix this, of course, option 1. So at the end, you take result, the value of the result that you have computed, minus quiz1.count 0.5. You added earlier on that you shouldn't add it, so you can do minus this value, 0.5. For example, okay. Option 2, in the iterations, okay, you can have an if statement. Okay, if I is 0 is 3, so if I is 3, for example, then you only add, you don't add quiz1, you don't execute quiz1.count I plus 0.5. Okay, you don't execute line 4. All right, so these are the two options. So in this code here, everything seems correct except the last part here, 3.5 is not needed, but it's added into it. So option 1, at the end, I minus quiz1.count 3.5. So I do print result minus quiz1.count 3.5 at the end. Okay. And then they still give the right answer. All right. And this is option 1. Now option 2. Okay, so this is option 1. And the option 2 is that inside the for loop, all right, you make sure you don't add 3.5. So in my if statement, I will have something like this. If I is less than 3, or if I is equal to 3, all right? So if I is equal to 3, then I only add count1.count I don't execute I plus 0.5. Now, there are many ways to write this, but this is just examples. Now, I didn't say that these are all perfect codes, these are all optimized codes, but these are some of the ways that I want you to start training yourself to think in this direction, so that if you have given some codes, so usually in the future, when you write a huge number of programs, all right, thousands of lines, and if you want to make minor changes because some of these codes, they are interconnected. So if you want to make minor changes, what you can do so that you don't jeopardize the whole flow of the code. So this is something that I want you to think to start practicing, okay? Instead of changing everything, rewriting the whole thing, what you can do, what is the minor changes that you can do, all right, so that it won't interfere with other programs that is going to be interact with, and just make a very simple modification of the code so that it still ensure the correct answer. All right, this is something that I want you to start training yourself to think in these directions. However, all of these options here, they are not exactly very good. If I were to have to solve these problems, first of all, I wouldn't have used dot count. All right, so here I put a remark, range cannot generate decimals. Okay, we are unable to iterate over numbers from 0 to 3 and use the dot count method to this. If we want to, we have to add something such as if and else, or add more statement here and then deduct some of the numbers that is added when we make the modifications. Okay, so now I want you to think about it. If I don't have this dot count, can I write it myself? Okay, it's because you have to understand here, if you look at this code here, okay, you iterate 4 elements here, 4 elements here. Here, so you iterate 4 iterations, 0, 1, 2, 3. I takes the value 0, 1, 2, and 3. So 4 times iterations. And in each iterations, you do dot count I. So what is this dot count I? So built-in methods, they are optimized in a certain sense, but it still has some operations running behind. So dot count I is gonna run some programs, and these programs will count the number of times I appear in quiz 1. All right, so you have to understand. So what is the total operations are required in the whole for loop here? It's just not 4 iterations. every iteration you execute dot count I. And you try to imagine if you are given a list quiz 1, if you were to count the number of times an element occur. So you can imagine that you probably have to go through every element in quiz 1 and check whether it is equals to I. Okay, and then count this. So every time you execute dot count I, you go through quiz 1 again. So when I is equal to 0, you go through every element in quiz 1 to count I. When I is equal to 1, you go through every element in quiz 1 to count 1. When I is equal to 2, you go through every element in quiz 1 to count 2. When I is equal to 3, you go through every element again to count 3. Okay, so how many times we go through the list quiz 1? 4 times. And every element is examined 4 times, which is unnecessary because when you examine whether it's 0, you know that it has to be either 1, 2, 3, and so on. So instead of going through every element 4 times, why not we just go through every element once? Okay, so that's the idea of creating our own count method to satisfy the task that we want without using the built-in dot count method, because when you do that, you go through the list multiple times. And can we do this with just using one time? So the idea is to create our own count algorithms. Okay, so it's very simple. So instead of iterate over all possible score less than or equals to 3, which is exactly what we did here. So we iterate over all the possible score less than equals to 3, which is 0, 1, 2, 3, or if it's allowed range and so on, any numbers that are less than 3. Doesn't have to, if it allows decimal points, for example, we don't go through this. We don't iterate over all the possible scores. If we can take decimal points, for example, it will be infinite of them. We can't generate infinite numbers. All right. So instead, so what we're going to do, so instead we iterate over all elements in the list. Okay. So we go through the list once. We examine each element in the list once. Okay. So what we're going to do is that here's a strategy. So first step, we initialize a variable called counter to 0. Okay, so this counter will be our final solutions. It serves as a purpose to store intermediate value for which we're going to update it. We're going to update it at every single iteration. All right, so how are we going to update it? So we're going to iterate x over all elements over the list. Okay, iterate over every element in the list. And if x is less than or equal to 3, okay, if it's less than or equal to 3, that means x satisfies the requirement that we want. So x, we add 1 to counter. So notice here, I'm not interested in the score that is less than equal to 3. I don't want to add this value here to my counter. I only add 1 to counter because I only count them. I don't want to sum the scores of this number. I only want to know how many of them are less than or equal to 3. Okay, so I only add 1 to counter. If not, I will just ignore it. All right. And 3 at the end. So outside the for loop, I'm gonna print the value of counter. So it's similar as sum, but instead of summing the value of x, I actually just add 1 to counter because all I care is counting. So it's very easy. So I say counter equals to 0. And for x in quiz 1, okay. And if x is less than 3, right, then I'm gonna add it into my counter. I'm not gonna add x because I'm only interested in the number of times such an x appear in the list. I'm not interested in the value of itself. So counter plus equals to 1. So this is the same as adding 1 into counter. And at the end, I'm going to print counter. So it say that 5 of them, so 5 elements here in quiz 1 has scored less than 3. So we can do double check here. 3, 1. Actually, is it less than or equals to 3? Less than equals to 3. Okay. So there will be 8 of them. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is how you do it. Notice it's the same idea that you have seen earlier when you do summation. And notice here that when we didn't use the dot count method, we create our own way to count. We only examine each element once. We go through the list once only. Okay, so this is why it's important that you learn how to use for loop to do such a computations, to accumulate a number, to count a number, and so on and so forth. So as a summary, we use for loop to check if an element in the iterable, for example, checking whether a digit appears in the user input, or to sum the numbers is the summing the numbers in the list based on certain conditions, for example, and counting the number of elements in the list based on certain conditions. So we have seen these 3 examples using for loop. So in the first example, all right, we go through the list once. Okay, so in all these examples, we go through, so we iterate through the list, examined each element in the list, and check if it satisfies certain conditions. All right. So in the first case, so in the iterations, we check whether the element satisfy, for example, it belongs to a digit. If it is a digit, what we're gonna do is that we set the variable has digit is equals to true, and then we stop. Once we found it, we stop. And has digit is initialized before the for loop to be false at the beginning. So it's false. And when you go to the iterations, you found a value in the list that is a digit, then you set it to true, and then you break. Now, when we want to sum, again, the same thing, you go through the iterations, all right, and check every element in the iteration X, whether it satisfies the condition. If it satisfies the condition, you add X to sum. So basically, you update the value of sum to sum plus X, okay? And what is this sum here? It's initialized before the iteration to be 0. Okay. Now, in the example of the third case, where we use a variable count instead of sum, okay. So again, the same thing. We go through every element in the list. We check if it satisfies the conditions that we want. If it is, we can update the value of count to count plus 1. That means we add 1 to count. Okay. And what is this count? It was initialized before the iterations to be 0. Okay, so essentially you iterate over elements that you want to find, sum or count, your if statements to keep track. And inside the if statements, if it satisfies certain conditions, you update the variable. Okay, so here, I'll show you what is the initialized value. At the beginning, has digit is false. Once you found it, you set it to true, and then you break, right? And then I say to sum, initialized value of sum or result, so these are result or sum, is 0. Right, and initially count is set to 0. Now in the lab, you will be given 1 questions where the initialized value might not exactly be 0. Okay, in fact, if you put 0, you will get the wrong answer. So these are all already discussed and presented in the mini recording. So please go through it because I don't have time today. In the lecture, we're going to do quiz 6. So here I'm going to mention here. So in this code here, if I set result equals to 0, and I run this code here, it's going to give me a wrong answer. Okay. So this code here, which you should watch the mini presentation, it's going to ask the user for input number 3 times. So enter a number, enter a number, enter a number. And then it's gonna give, at the end of the iterations, you're gonna give the product of all these numbers. As you can see, the user enter 1 and then 2 and 3. So the product should be 6. 1 times 2 times 3 should be 6. But it gives me 0 because I initialize the value result is equal to 0. Okay, so how do we fix this? It's an exercise for you for this lab to think about it. And I already discussed it in the mini presentation that you need to watch. So the idea is that this initialized value, okay, not necessarily always have to be 0. Okay, that example will show you that if you put 0, you actually get wrong answer for that particular example. Okay, so what is this initialized value has to be? So it should be such that, for example, for sum here, if you want to add element into this sum, all right, the first number that is added, for example, sum to sum plus x, the value of initialized value of sum should be that sum plus x is equals to x for the first iterations. So say we have for x in say 1, 2, 3. Okay, so what is the, I say result is equal to 0. Okay, and then I say result plus equals to x, and then I print result. All right, so let's print out individually. So x is equal to 1, you add 1 to result, and it stays at 1. If I take a different value, say 3, whatever x is, whatever value x that I add to result, it will stay as x. So this is the value such that this number plus the first number in the iteration will always stay as the first number of iterations. Okay, so 0 plus anything will stay at that. But in the lab, what you will see that 0 times 3 is actually 0. It's not equal to 3. So what value of result need to be so that this value times 3 is equals to 3? Okay, so this is something that you need to figure it out and just to play around with it. All right, and let's get started with our quiz 6 today.